We started talking about objects in the previous video, and I didn't want to get too deep into this yet because it can be a lot. There's a lot of terms to throw around, and I didn't want to make things too much at once. So we talked about objects last time, right? We talked about them having attributes and behaviors. And these attributes and behaviors are inherited from the class that it is an instance of, and that there are certain attributes and behaviors that are specific to that particular instance that may differ from the class itself. And we've worked with these some already, even looking at turtles and Tkinter. So if I use the turtle as an example, if we create a turtle named Fred, Fred inherits from the turtle class certain attributes, like Fred's shape is going to be a triangle, and Fred's ink color is going to be black. Now we can change those, and that's fine. A certain object can have attributes that differ from its parent class, but it's going to inherit them from the parent class, and of course we can change those, and that's fine, but an object is going to inherit those attributes from its class unless they are changed. Now there are a few other terms to discuss to hopefully help you understand some of the ideas of object-oriented programming. Now last time I discussed a pin, right? And I gave different examples on what a pin might look like. Now there are a couple other terms that I want to use, and I can relate them back to the pin for right now. The next term to briefly discuss is abstraction. Abstraction is about not worrying about the unneeded details. If I'm using the pin as my example again, and let's just say for example that you need to write something down and you don't have a pen, and you ask me if you can borrow a pen, you don't have to get into all the little details, right? You don't have to specify if it's a black pen or if it's a plastic pen or if it has the little clicky on the end. You can just say, can I borrow a pen? And I have an idea of a pen and you have an idea of a pen, and the pen I might hand you might look a little different than what you're thinking, but it doesn't matter because it doesn't matter. We both understand the idea of a pen, and I can find a pen for you without having to worry about what color is it? What exact shape is it? Is it a cheap and expensive pen or not? I have the idea of a pen and what a pen should do without you having to get into all the specifics. So that's the idea of abstraction. And we'll cover some of these with a different example in a few minutes as well. This also gets into the idea of polymorphism. So the idea of polymorphism is that you can interact with the object without needing to know all of its specifics. Whether I hand you an expensive pen or a cheap pen, and if I don't have a pen and I hand you a mechanical pencil or a regular pencil, you can write with those too. So if we were to broaden our idea to just some sort of writing utensil instead of specifically a pen, which is probably actually what you meant, I could hand you a pencil or a mechanical pencil or something instead, and you would be able to interact with that the same way regardless whether it's graphite, whether it's ink, because those aren't really necessary for your general purpose. Now, of course, this isn't always true, but hopefully you get the idea. And I guess the last big idea that I want to mention is encapsulation. So encapsulation is the idea of containing and sort of hiding details. There are certain things that you don't need to know to be able to write with it. So, like, you don't really need to understand exactly how the little clicky thing on the back of a pen works to be able to use the pen, right? I mean, granted, you could learn about it, but you can write with a pen without understanding that. You don't exactly need to know how the ink is made to be able to use the pen. These are details about the pen, and they may or may not be interesting to you, but either way, you don't need to know it to be able to use the pen. And so the idea is sort of to hide the data that we don't need. So let's go over one more example. And perhaps my favorite example for this is dogs. As we're talking about object-oriented programming, let's look at a different example other than just writing utensils to hopefully help you wrap your head around it. So if we look at dogs, we have sort of this class of things called dogs, right? And within dogs, we have instances of them, right? So we can see here a variety of dogs, and there are certain attributes and certain methods related to dogs as a whole, right? Dogs have fur, dogs are mammals, dogs are living creatures, and there are certain behaviors related to this large class. Dogs can bark, they wag their tails, they pant when they're tired. So there are certain things that are related to the overarching idea of a dog. And I can say dog, and you get the idea of a dog without me having to tell you the specific breed or the specific color. Now, there are also certain attributes and behaviors specific to the individual instances of these dogs. So if we look at like a Chihuahua, their size attribute is significantly less than a Collie's attribute or a Boxer's attribute of size. And the way that their bark sounds is going to be different than that of another species. The temperament for that particular breed is going to be different. So there are certain attributes that might be different for one instance versus another, even though they all belong to the overarching class of dog. Now, I stated that the Chihuahua is an instance of the dog class, but the Chihuahua could be its own class as well, because maybe I have a Chihuahua named Milo, and he would be an instance of the Chihuahua class, which is also an instance of the dog class. So you can have a parent class like dog, and you can have a child class like Chihuahua, which is an instance of the dog class, and then I could have Milo, which is an instance of the Chihuahua class. So in this example, Chihuahua would be a child class of the dog class, and dog class would be a parent class containing other classes underneath it, like a Chihuahua or a Boxer or a Beagle or a Collie or etc. And some of the attributes of Milo might differ from the Chihuahua class. So whether it's a long hair or a short hair, what color Milo is, what Milo's temperament is. Even though Chihuahuas have a general tendency for certain temperaments, Milo's might be different based on the experiences he's had in his life. So if we're talking about some of those bigger ideas of object-oriented programming again, we've already kind of touched on inheritance here, right? We've talked about there are certain things that Milo inherits from the Chihuahua class, and there are certain things that Chihuahuas in general inherit from the parent class of dogs. And we've already touched on abstraction, saying that I can say dog, and you get the idea of dog, and I might picture a Chihuahua, and you might picture a Great Dane, but we both have this idea of dog, and that might be close enough for our discussion. When it comes to encapsulation, there is a lot of different aspects about dogs that may or may not be relevant to me. If I own a dog, yeah, I probably need to know a good amount about dogs in general. What is their diet? How to take care of them? Maybe what are certain elements that my dog might be susceptible to based on his breed or his lineage. Now, if I'm just taking care of a friend's dog for the afternoon, some of those might not be relevant. Granted, I need to know what sort of food the dog likes to eat, and I probably need to know like around what time of the day the dog is typically walked, and so I don't need to necessarily know what long-term concerns there might be about this breed, because that's not related to what I'm doing. And we can also talk a little bit about polymorphism. If we want to broaden this out to having an even higher parent class, so if his dog's name is Stacy, and Stacy is an instance of a Corgi, and Corgi is an instance of a dog, and a dog is an instance of a pet, if my friend calls me up and says, I'm going to be late, can you go over and feed my pets? Whether it's a dog or a cat or a fish or a bird, I can probably go over and figure out how to feed the animal based on what it is. Now, it might be nice to know what it is, because I might have questions like, where do you keep the food? Or what sort of food is it? Is it dry food? Is it wet food? And in the same way, if I wanted to give the pet a little bit of attention and not just walk in, feed it, and walk out, I can probably do so regardless of what type of pet it is. So if it's a dog, I can pet it. If it's a cat, I can probably pet it. If it's a fish, maybe not so much, but you get the idea. There are certain things that you can do regardless. Now, if we want another example related specifically to programming, let's say that we're talking about a bank account. So the bank account would be the class. If you have an account with this bank, that would be an instance of that class. It's going to have certain properties. It's going to have certain behaviors. So the current value in your account is an attribute. How much interest you're gaining is an attribute. Whether or not you have a monthly fee would be an attribute. If it's a savings account, all of these could be attributes. And of course, there are certain behaviors that go with this as well. So depositing money into it, withdrawing money out, those are behaviors related to it as well. Now, of course, you could say that those are behaviors related to the class. And yeah, those behaviors probably are more of class behaviors as opposed to behaviors specifically for your instance. And of course, the account having some sort of balance and having some sort of interest, yeah, those are attributes inherited from the class, but the actual values are defined by the object itself. Just the category was inherited by the class, and then the value was dropped in. If we want to talk about abstraction, how exactly the interest works, how exactly the little teller machines work for you to be able to withdraw money or deposit money, some of that isn't necessarily needed for you to know to be able to use your account. Now granted, if you have an account, you should probably understand how the interest on your account works. But you could still have an account and still make withdrawals and deposits without knowing that. When it comes to encapsulation, there are certain bits of data that you want contained and protected within your account as well. So you don't want your balance available to the public, so you want that data encapsulated and hidden within it. You don't want your PIN number available to the public. You want that hidden within it. And of course, you can still pass stuff in. We can make a deposit and insert money in, and the math can be done without us having to know what the balance is. We can probably make a withdrawal. Depending on your balance, we might be able to make a withdrawal without knowing the actual balance, although, be careful with that. And of course, putting in your PIN number to make a withdrawal from a teller machine also has a bit of encapsulation. We put the number in, and it checks it, and it either confirms or denies, but it doesn't go out and out what it is on the screen for anyone nearby to see, right? So there's certain data that we want hidden. So hopefully that gives you a fairly decent idea of what objects and classes are, and some of the things that we look at when we're doing this. And we'll talk about little bits here and there as we need to, as we're going through, but hopefully that gives you a broader, rough idea of object-oriented programming.